Okay, hello everybody. My name is George, or Georgi, but it's Slavic, so it's quite hard to pronounce. So I'm the co-founder and CEO of Imaga. Imaga is one of the, I can say, the very first company starting to do something in the space of automated image annotation back in 2011. So I'll just start with a bit of a show-off to give you a context. But in 2006, Clarify, Antelic Labs, and we were identified by IDC as the three most innovative companies in the field of image analytics. So currently the company has more than 200 business customers and almost 10,000 developers using the technology actively. And the second number, this is widespread in almost any country that is actively using some kind of technology, building mashups and APIs. So not to restate too much of the things that we already covered today, I intentionally skipped some of the slides of my presentation, like what's the problem and everything. I think that the guys did a great job covering this. And in terms of simplicity, the process is you submit some kind of visual content like image, video frame, video file, like a black box, the technology analyzes it, and it outputs certain type of keywords and metadata. So the focus on my talk to a certain extent is about what is existing currently as a service and also as a technology and capabilities, what have been the trends in the past and what we think is current and maybe what is going to be next. So first of all, I don't know, maybe most of the companies who are trying to present this to business customers, they ask like, what's the difference? Or to investors, they ask, what's the difference between a framework? You have so many frameworks like Cafe, Theano, Torch, MXNet, and a few more like from Microsoft, for example. And what's the difference? What's the value proposition that you basically offer to us because all these frameworks exist? But all these frameworks, you need to do the data collection, you need to do the model optimization, you need to have a team of experts that understand to a certain extent what machine learning is all about. It's not, it's a black box to a certain extent still even for scientists, but still there are certain mechanics how this black box should be used so we can get the results that you want. In comparison, if you have some kind of a service, typically the time to market to have such kind of technology integrated in your own product is very low. So it can be in the matter of a few hours to the matter of a few days. And the biggest problem is not the integration of this technology. The biggest problem is how companies adopt their user experience, their value propositions, or how at all they are prepared for the enabling power of this technology. Because these technologies are more or less enablers. Or they are optimizers of certain processes. But the companies and the organizations should be ready to do so. And something that I hope that maybe we can see as a result of this, even if this conference today, is that more and more companies want to adopt the technologies. As Mike said, either being Clarify or Imaga or IM or whomever, we believe that if these technologies are used more actively, more aggressively, more easily, with more, I don't know, ideas, brainstorming how this could be used instead of why it's not useful, why it's not perfect, does it stealing jobs or something, we believe that the whole field is going to advance. So here maybe not exactly in the beginning, but I still want to thank for this opportunity that stakeholders and vendors that are typically perceived as competitors, we've been invited here so we can talk together and eventually we can discuss together this topic. So I would like to do like a brief overview of what has been the past of how this services has happened. So, the machine learning, the deep learning, currently it's one of the biggest hypes in industry, one of the biggest fashionable trends in industry. But even before that, there were certain tries of people trying to automate the process of annotating images, or at least outsourcing it somehow. So, one of the very first tries in this was with using Amazon Mechanical Turk. I remember the first of our customers, they were typically using Amazon Mechanical Turk or some kind of overseas teams in India or the Philippines to annotate photos. And actually some services still do. The problem with humans is that they're not consistent in their input. If they're not specifically trained, and exists service like Crowdflower, for example, they try to train people, but still it's not very time predictable, it's very custom to define this process, and so on. If you have a standardized set of criteria, and if you can match them to an existing technology, it's so much less hassle and much more consistent result. So there are other services. I don't know if any of you heard about Takao, for example. They were doing a combination of using human force outside, inside, and some kind of basic similarity technology. We also initially started having something very similar to what Kai shared, applying the concept of visual similarity for the purpose of annotating images, and it was doing a good job for browsing photos and doing similarity search among photos, but it was failing when the composition and the colors are not the main thing. Still, in a lot of cases, it was quite useful, so we can do some kind of basic conceptual annotation of images. There are a few more companies, immense in the UK. I'm not sure what's current status of those guys, but I haven't heard. They were mostly, you know, so?
They're doing different things now.
Yeah, it could be. But they were trying to do exactly the image tagging when we first started trying doing the same thing. And there are companies like CloudSight right now, with their application CamFind, which was based exclusively on human backend. That's why the result typically take like a few tenths of seconds to respond. Then later on, when I would say the seminal work of Krzyzewski first, and then next year Matt bringing from Clarify bringing this even further, the results of on the ImageNet large-scale visual recognition competition. There a second wave and the second coming of machine learning, and we were one of the very first companies who also used what we've built before based on traditional image processing to advance further and start offering it as a service. Shortly after that with Clarify, recognition, CloudSight, mixing the Filipino data team with actual machine learning. Then some companies like MetaMind, which was acquired by Salesforce, they were specifically focused on the custom trainings. They do a lot of enterprise custom trainings. Their whole product was about this. They barely had a generic tagging solution. Microsoft and IBM Watson are also doing some job. I think, you know, Ramsey referred to this. You know, I mean, to some job. I don't know. Obviously, you know, Google Cloud Vision and Amazon Rekognition are currently having pretty good generic tagging solutions as well. I'm not sure what's the strategy of these companies regarding customizations and custom trainings, but maybe they can share later on. So these are different types of services that are based on machine learning. And then in terms of features, it's very important for people to be able to make distinction and differentiation between the different types of image and visual recognition analysis. That's why I try to do maybe not a complete, but at least a brief overview of what are different capabilities. Because, you know, we as human beings, we perceive our world mostly, if we are not blind or something else unfortunate like that, but we perceive our world visually. So we tend to equalize like everything that we perceive is visual recognition, which is not exactly correct, right? So, and it's not exactly correct that everything that's visual recognition, it's not at all correct actually that anything that's visual recognition is solved within the same approach or within the same core. Even if it uses machine learning, it's different type of data sets or different type of definition of the problem, how this could be solved. So here's a, when I remember when initially we say we do image recognition, like 5, 6 years ago, and people are, oh, so you recognize faces. And we're like, no, at this stage at all, we don't recognize faces. But this was what most people thinking image recognition is. So obviously face detection is one of the very things, the first things that existed also now in any digital camera or something else, where you can detect people and you can act accordingly based on that. Text extraction, I can say for many years also has been quite, like optical character recognition has been quite well-performing technology, especially in the case of traditional text recognition, not handwriting recognition. Then we have color extraction or other kind of measures for visual search and visual similarity. We have things that can analyze the composition of an image for the purpose of either extracting some kind of, obviously the central composition is not the best in photography, but in a lot of cases like product photography, you can do some things to recognize composition and concentrate based on that. Then in general, the case of categorization photos, we typically split this from the case of annotating photos. Because annotation is mostly for search or extracting some kind of statistics, while categorization is for better browsing experience or, again, extracting some other types of statistics. So, for example, classification, the good thing is if you can define well a classification problem, you can almost use out-of-the-box machine learning solution to solve it. So one of the biggest problems in classification is actually the definition of the problem, so it can be resolved by some kind of classification. Then we started and I think most of what our services as a branch Clarify, IM Vision, Google Cloud Vision, Amazon Recognition, and us, still at the core of it, it's some types of classification or large-scale classification of a lot of concepts. And then this has been extended to suggesting more keywords, either based on the actual output of the classification or some features extracted during the classification, or some additional combinations of different classifiers or extension of keywords based on what Kai showed in the beginning based on visual similarity between images. But the end result is typically that you have an output of a single set of a few keywords that are coming directly from the recognition and a few more that are coming from some kind of inference or some kind of correlation between keywords, concepts, and visual features. To the best of my knowledge, still there are no services that are good in anything else than faces on the commercial level, on the high scale, that can suggest positional tagging, though this is something that has been in the research, visible in the research area for a couple of years already. But still, the computation capabilities and the data sets that needs to be built are order of magnitude more complex compared to just detecting that something on the photo, to localize it with a good level of precision. I believe that this is something that one way or another, multiple of our services will release at a certain moment. It's especially valuable in multiple verticals like retail, like interior, furniture, and these kind of things, and fashion in general. For some other cases, it doesn't add a lot of value, but the good thing is that typically it can improve the recognition rates of particular small objects if you can have some kind of localization of those. Then you have the other funky thing that was basically covered as well, but image caption generation. It looks impressive. Again, the practical value of it depends, especially in stock photography or promoting photographical content or creative content. This could be useful because it has been a de facto standard in almost any stock agency to provide, in addition to the keywords, to provide some kind of textual description. Again, we haven't seen this still being some kind of commercial level, high scalable API, but maybe that's something, if there's enough demand and money in the pockets of the paying customers, that would be developed. This is a screenshot from from IM Vision demo. So this is, I think, another interesting aspect, especially in the context of more artistic photography, that can give you the idea that we can identify things that are typically abstract. But as Kai said in the beginning, one of the definitions is and it also refers to what I mentioned about problem definition. If you can define something as recognizable by people, so if an expert just using visual perception and no kind of other specific, non-domain specific knowledge, if they can solve the task and you have enough data, you can solve this problem. But then the question, and the main question, is how to get this data. I'll refer very briefly to that. And I think that Ramsey, for example, and IAM have as he said, had the opportunity to have a lot of data about the aesthetics or the sellability, or how sellable a single photo is. So it's a very good training set. So in terms of practical use cases, in some other presentations I focused a lot on this. As I said, this is for me one of the most important mission of our companies, is to try to make people adopt more and more such type of technologies. Maybe some of the things are quite obvious or already said, but I just want to briefly cover some of them. Internal organization of photos in different types of digital asset management systems, either built in-house or using a third-party digital asset management solution. But this is one of the key benefits of using such a system, either in fully automated way, where you focus most on the output of these tagging technologies and their confidence levels and use this for ranking, or use some combination of automation plus human curation. But especially if you talk about a very huge collection of photos and you want to make it searchable, if you just leave this on people, especially if these images are not for sale, which is lowering the motivation of the people to annotate them, it's something that's very valuable. And we see some use cases among the companies, including ours, where digital asset management solutions using this technology, but we believe that it should be even more widely adopted. In, I don't know, maybe in 2-3 years, people will for sure use this, and this will be a de facto standard. So if you're operating such kind of a business, I think that you better start using it right now. Organization of photos for sale, in general, like in any type of stock photography agency, especially if you want to go on the mobile device, as I am are going, for example, you know, if you want to go mainstream, if you don't want to focus this only on semi-professional or semi-professional or professional photographers, to having the opportunity to submit crowdsourced content and offer for sales crowdsourced content is so much more enabled and more effective if you can have in the loop the process of annotating these photos in some type of automated workflow. Content moderation, obviously, as Amazon Recognition also mentioned that they're building this kind of solution for the purpose of knowing if this content is right or not. This is a very repeatable use case because our services, typically the value proposition is you have a lot of content and you don't have the matching resource to annotate it. So you have so much more content than resource to annotate it or resource to do any other kind of curation. And of course, this content creates a lot of opportunities, so it's good to use it. But in a lot of cases, this crowdsourced content can be somehow explicit or inappropriate. So I think that one way or another, almost any case that relies on crowdsourced content requires certain type of moderation, and this is a very good candidate for automated solutions. I'll skip the last one. Here are some of the major vertical industry use cases, but I'll jump on a few particular cases that I think are interesting. So maybe some of you heard about Unsplash. This is one of the fastest growing services for downloading photos. I wouldn't say selling photos because they're practically free. So the motivation of the photographers to annotate photos there is lower compared to traditional stock photography agency. Even if their photos to be promoted there or something, but they don't necessarily relate this with some kind of financial returns. So these guys contacted us a long time ago and they say, we want to automate this process. They do certain evaluations, and now all the photos that go through the Unsplash upload process has been automatically annotated with our technology. And above a certain threshold, they use these keywords to enable search capabilities in the system. I would like to throw a bit of a bomb here, but maybe we can discuss this in the breaks and so on. The Clash of Tags was a game that we organized together with Algolia, which is one of the leading search as a service API companies. So we did a test where we show the people, they can type a keyword, and we show them results from, we show them results that are coming from an image set that has been annotated by a human, and as we call it, by a robot or by our technology. And they need to say which of those two sets exhibit the better results. So if I type a horse and I have on the left-hand side one set and on the right-hand side other set, which of those is better? So it's a blind test, so they don't know which is which, right? And then at the end of this, we did like several thousand games. It turned out that in 51%, people prefer the results generated based on human input tags. And it looks like the human has won, right? But if you think on it on the other perspective, it means that in the other almost 50%, the computer has either been better or on par, because we had this third option, or on par with the human-generated tags. So it's not 100%, but still there are half of the cases where computer can beat or match the human performance on this. So I'm fast forwarding to the end of my presentation. I just want to say that this type of technologies can be used just even for extravagant things as sorting out waste or evaluating waste based on the training mechanism of the system, or on profiling what people like based on their visual collection. So my Facebook photos show about me that I'm a gym rat, that he's an artist, that somebody else is a family guy, and you can offer me a car based on that. Last but not least, and this is the end of my presentation, I think one of the biggest challenges that we need to solve, and I'll be happy to hear about your brainstorming on this topic, is how we can better create data sets, not in a sparse or sporadic way, so we can build and train for these technologies. Because I wouldn't say there's any magic in machine learning or something. It's so much reliant on data. This is not something new, but the question is how we collect this data, how we collect complete set, diverse sets of really useful data. Because Google processing several billions of images doesn't mean that this is a qualified training data. Okay, that's it. Sorry for running a bit out of my time. Thank you, and I'll be happy to answer questions.